Hi, this is Rachel Fiore doing the second grade content. So once again, I've copied the front page of the content for second grade and highlighted some key differences and points about this content compared to other content in the earlier grades. In this content, in this grade, students are going to be starting to learn to ask questions. If we looked at kindergarten and first grade, there was some of that, but mostly about observations. Also in this grade, they're starting to use some measurement, length, weight, and time intervals. You'll see this when they talk about mass and when they talk about speed. So this has been the first time that we're starting to use really measurements to compare things. In the second paragraph, we can see kind of the themes, pushing and pulling, motion of the sun and its effects on sun and the moon and its effects on Earth. We can also see that we're starting to see material that has already come up. So the students should have prior knowledge. If it's a whole school experience, then the students in kindergarten would have had some experience with both of those things. And then we're starting to look about physical properties of matter again, but now we're starting to pull that together to pull with like solids, liquids, and gases. And then we're going to go ahead and look at changes caused by humans, plants, and animals, and weather, and life cycles. So there are some standards I'm going to show you some images of, and whenever I pull images, in particular when I pull images from the space, everything to do with space, I'll pretty much only pull images from NASA. There's a lot of bad space out there, and in particular some of the stuff you see, like a really common one I see are Oreo cookie demonstrations, and then they'll have the patterns reversed or not correct. So whenever you're looking at where you start as far as any image portrayal in space science, go to NASA. So here are some facts. There's a little bit of difference between the standards this time and the standards that were the GPS. So the standards in GPS talked about color, and you'll see that that is not part of the standards here. It doesn't mean you can't do it, but it means that it's not a focus. The focus here is really about the different sizes of stars and the fact that stars are different distances from Earth, even though they look at the same distance. So again, I've got 10 facts, and pretty much some of the only ones that really give trouble is the idea that the sun is farther from Earth than the moon is from Earth. So because the sun is so bright, and so large, it seems like it might be closer. And I'll show you some actual numbers in a second. And then also the size of the sun is pretty huge, and sometimes people draw the sun closer to the moon, the Earth, the moon is, but actually it's so big it can't even fit between the distance between the Earth and the moon. The moon is actually way closer than we think it is conceptually, and the sun is much farther than we think it is, conceptually. The other thing about the sun is it's not a particularly special star. It is a medium size and medium brightness. And there are stars that are bigger than ours, and there are stars that are smaller than ours. And most stars are incredibly, almost incomprehensibly far away. So here are some distances. These aren't distances that you need to teach students, but they do give you the background knowledge that when you're talking about stars, you're doing it with some numbers, and you're welcome to share these. So, and you can double check them too. But anyway, the key one is that the sun to the Earth is 93 million miles away. So that's incredibly far. Whereas the moon to the Earth is hundreds of thousands. So we could have a car, hypothetically, that has that many miles on it, moon to Earth, but we're never going to have a car that has the sun to Earth distance. To comparison, and you see how, if we were to fly from Atlanta to Los Angeles, that's 2,000 miles. I just wanted to give you that perspective. And we look at how far some of the planets are. I think one of the things is we just assume that the star, once we decide that the star is far away, we decide that the planets are really closer than the sun. They're actually really not closer than the sun. Like Mars is closer to the sun, but if we think about the order of the planets, Mercury, Venus, Earth, Mars, Jupiter. If we look at Jupiter next, it's way farther away than it is from the sun. And so one of the things is when we're drawing these diagrams of the Earth, Moon, Sun, and we start thinking about planets later on, we have to really understand that a lot of the images that we see online are not to scale. And by comparison, we talk about the next closest star, and that is incredibly far away. So in general, I also gave you some distances across. The Earth is about 8,000 miles across. The sun is about 100 times larger than that, and the moon is about a third their size. So the moon is actually a little bit bigger than we realize. So again, I got this image from NASA, and one of the things as understanding that the stars all look like they're the same distance. So we can say, oh, the star is far away, but they're incredibly far away. And even when we look at them, they look like a flat plane. They look like they're all the same distance. They're actually way farther apart. So even though if we were to draw them, we draw them flat, but we were to actually model them, we would model them at different distances. And then they look farther and closer away, not only, they look different sizes and brightnesses, not only based on how far away they are, but how big they were to start with. So, for example, we can look at Betelgeuse, which is 400 light years away, and let's see, try to find this. So Rigel, which is 800 light years away, is a pretty big star, whereas Alnitak, I don't know how to say that exactly, is 800 light years away, is a small star. So their different sizes affects how big they look in the sky, but mainly also we want to just also factor in how far away they are. So this next standard is about the sun, daytime and nighttime, but we're going to go ahead and kind of get more information than we had in kindergarten, and also finally kind of getting into moon phases. Now there's a kind of a do's and don'ts with moon phases, and so what I've kind of decided based on reading these standards is it's okay to talk about the spinning or rotating of the Earth facing toward and away from the sun, cause day and night. Whereas we're not going to talk about orbiting, we're not talking about revolving, we're not talking about the moon going around the Earth. So we're really focusing on just the fact that at second grade that the Earth spins on its axis. And so when we talk about the Earth spinning on its axis, we have all these things that we have these signals that the Earth is turning. I mean, obviously at one point we thought the sun was moving, but now we know that the Earth is the one moving. But we can look at the evidence of what happens. And not only, even though we're not explaining things, we're looking at some changes over seasons. So we're looking at how long daytime and nighttime are, and you can find that information on the internet, what the numbers of hours of sunlight are during the summer, the winter, spring, and fall. And then a kind of an important point, which I think is okay for second grade, is for understanding that the moon is not giving off light, that we see the moon because of light from the sun. So I've put some of the facts in here, and I think there's a tendency to go too far in this standard, and you kind of notice they specifically say that we're not talking about the phases of the moon, but we are talking about moon patterns. So let me go to this. No, I'll go to this one. Okay, so this again is, you'll often see the sun very, very close to the Earth when we talk about day and night, but this is as an image from NASA, and I really like just that it has sunlight. So when the sunlight is coming here, it's daytime on this part of the world, and it's nighttime on that part of the world. The other thing that NASA does that you can really get messed up in, and it's not that teaching it wrong is horrible, but if you're going to teach it, you're going to teach it right. When we spin the Earth, we spin it counterclockwise. And so NASA does this correctly. You're going to see a lot of, not a lot, but it's not uncommon to find things that have the Earth spinning the wrong direction. And again, when we go ahead and we spin here, this is sunlight and this is nighttime. So it's daytime here and nighttime here. And as the Earth spins around, then this becomes daytime, and then this area becomes nighttime. If we go now to this pattern, so again, we're talking about patterns, we're talking about the moon phases. So again, it's the same thing. We don't really talk about this, but you should know that the moon is actually going around the Earth counterclockwise. So the most accurate way to represent moon phases is in a circle that goes like this. And so we start here with the new moon where we can't really see the moon. And what you want the students to notice, and you really should take the time to have them notice these things in the night sky, or even sometimes in the day sky when they're visible, is, and certain phases are visible in the day sky, is that we see a little bit of light on the moon, and notice it's on the right side. That's the key. So we're going to see the right side getting brighter and brighter and more and more and more lit up till we get to here, and then about half of it's lit up. And we're going to keep going. We're going to see more and more and more until it's more and more lit up until we get to here, and that's all lit up. And I'm not sure why this is bigger, but notice how this is now getting darker on that side, but it's lit on the left side. So as we go here, 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 lit on the left, lit on the left, lit on the left, lit on the left. So when we're looking at moon phases, we know what phase we're in by how much and where the moon is lit. So on the right side, when it's lit on the right side, like here and here, we know that it's going toward a new moon, a full moon, which is here. And we know as it's getting darker, if we see it lit on the left side, even if it's just a little bit on the left side, even there's just a little bit of light, we know that it's heading toward a new moon. So new moon, it's getting to full moon, it's getting brighter on the right side, and full moon to new moon, it's staying brighter on the left side. So the next standard is about weather, plants and animals, and changes the environment. And so when we're looking at this, we want to really think about the fact that this is about their environment. So one of the things you want to understand is, what is the environment? So the environment is just the area where you live. And so this standard, I think, is really sometimes misunderstood, and I have a little note here. It's not about earth processes like earthquakes and volcanoes. So that's something happening inside the earth. We're talking about external things to the earth, how it changes how the earth looks. And so one of the most easy ones to study is weather, and to follow weather events. And if we have like mudslides or hurricanes or tornadoes, anything like that that changes not only like what the earth looks like, but you can also just look at what we've done to the earth. You know, the fact that you might see a house that's been washed away or a truck that's been overturned. We can still look at those because ultimately those things end up changing the earth. Some of the things that we do to the earth are we can farm it. That's a change that we make to the earth. We can plant things, like we can reforest things, so we can build things up and we can take them down. We can mine from the earth. So a lot of it's about the changes that we have to earth. One of them just looking at around the school and where there are changes. And then there's also this idea that we have done things to the earth, the kind of, when we talk about the earth and our structures and plants and animals, like kind of all work together. So when you look, you can look here at like roots that have broken up concrete or roots that have broken up soil. So you're looking at changes in the environment due to these things, weather, plants, animals, and humans. So it may be something like you've got like some little holes in the ground that are because something is digging in there. So again, this standard is really pretty straightforward. It's kind of a version of what we call place-based learning, where the students are noticing changes around them. And then as we go into the upper grades, we'll talk about earth processes. But this is not about earth processes at this time.